Hello friends, today I am going to discuss a new chapter called polynomial. So what's a polynomial? So it's an algebraic expression in which power of a variable is a non-negative integer. Example, you can see 3x square plus 5x plus 6 is a polynomial because here x ka power is 2 and here the power of x is 1. So both are non-negative integer, so it is a polynomial. 3x square plus 5x minus 1 plus 6. It is not a polynomial because here the power of x is negative. 3x square plus 5 upon x plus 6 is also not a polynomial because if I write in this form, it will get x to power minus 1. So not a polynomial because it is a negative integer. 4. Yes, it is a polynomial because it can be written in the form 4x to power 0, and here the power 0 denotes a non-negative integer, therefore it is a given polynomial. Now we are going to know what is the degree of a polynomial. So it means the highest power of a variable in the given expression. Example, 4x square plus 5x plus 6. Here the highest power of x is 2. So we can say that it is a quadratic polynomial. 3x plus 5, here x the highest power is 1, so degree is also 1, therefore it is a linear polynomial. 5x to power 3, here the degree of x is 3, therefore it is a cubic polynomial. 0 of a polynomial. If x equals to alpha is a solution or a factor to a given polynomial, then alpha is called 0 of the given polynomial. Example, x square minus 3x plus 2. First of all, I am going to split the middle term. On splitting the middle term, we get minus 2x and minus x. So we can, on solving, we are getting x minus 1 and x minus 2. Now, putting x minus 1 equals to 0, we get x equals to 1. And x minus 2 equals to 0, x equals to 2. These are the two alphas, or alpha, x equal to alpha, which are the zeros. Here the zeros are alpha equals to 1 and alpha equals to 2. If you put alpha equals to 1 or 2 in the given algebraic expression x square minus 3x plus 2, you will get 0. So x equals to 1 and x equals to 2 are called 0 of the given polynomial x square minus 3x plus 2. Now relations between zeros and coefficient of a quadratic polynomial. Let x equals to alpha and x equals to beta be zeros of a given quadratic polynomial ax square plus bx plus c equals to 0. Then x minus alpha equals to 0 and x minus beta equals to 0. Multiplying both x minus alpha and x minus beta, we get x square minus beta x minus alpha x plus alpha beta equals to 0, or x square minus alpha plus beta into x plus alpha beta equals to 0. From 1, this equation x square plus bx plus c equals to 0, we get x square plus b upon ax plus c upon a equals to 0 when we divide this equation by a. Now from 1 and 2, if we compare 1 and 3, if we compare, we get b upon a equals to minus alpha plus beta and alpha beta equals to c upon a. So we get the relation between zeros and coefficient as alpha plus beta equals to minus b by a and alpha beta equals to c by a. So a quadratic equation can be written in the form x square minus sum of zeros into x plus product of zeros. To verify the relationship between the zeros and coefficients, we have an example over here, x square plus 3x minus 10. In this, first of all, we need to split the middle term. I have already split the middle term here, 5x minus 2x, and we get x minus 2 and x plus 5. Putting here x minus 2 equals to 0, x equals to 2, we will consider this as alpha, and x plus 5 equals to 0, x equals to minus 5, we will consider minus 5 as beta. Now x square plus 3x minus 10, this was the original equation, so we are going to find a equals to 1, b equals to 3 and c equals to minus 10. Alpha and beta, which we found in the previous page, was 2 and minus 5. So first of all, first relation is alpha plus beta which we get as 2 plus minus 5 as minus 3, and minus b upon a is minus 3 upon 1 as minus 3. This verifies our relation alpha plus beta equals minus b by a. Another relation is alpha beta. Alpha multiplied by beta we get as 2 into minus 5 equals minus 10, and we get c upon a as minus 10 by 1 equals to minus 10. This verifies our second relation alpha beta equals to c upon a equals to minus 10. For solving an equation on polynomial, we need to remember the above relations and use them to solve the given problem. If 2 by 3, example I am taking, if 2 by 3 and minus 3 are the zeros of quadratic polynomial ax square plus 7x plus b, find the value of a and b. We are given alpha equals to 2 by 3 and beta equals to minus 3. So we are going to find the sum of zeros. On solving it, we get 2 by 3 minus 3 equals to 2 minus 9 upon 3 equals minus 7 by 3. Whereas we get minus b by a as minus 7 by a. Now equating this, already we have found this relation here, a alpha plus beta equals to minus b by a. Putting here the values, we get a equals to 3. And from the second relation alpha beta equals to c by a, we get 2 by 3 multiplied by minus 3 equals to b upon a. On solving these values, we get b equals minus 6. So by using the coefficient and the relations of zeros with them, we can easily solve a given polynomial questions. Now we are going to see the other method for solving the same question. Ax square plus 7x plus b, and zeros given were 2 by 3 and minus 3. So first of all, we are going to put x equals to 2 by 3. On putting x equals to 2 by 3, we get a 2 by 3 whole square plus 7 2 by 3 plus b equals to 0. On solving, we get 4 upon 9a. This 2 square is 4 and 3 square is 9. 7 into 2 is 14 upon 3 plus b equals to 0. And on putting x equals to minus 3, we are going to get another equation, a into minus 3 whole square plus 7 into minus 3 plus b equals to 0. 9a minus 21 plus b equals to 0, or b equals minus 9a plus 21. We have found this b in order to substitute the value of b in equation 1. So here we are substituting the value of b here. So 4a plus 9, this from this equation, plus 14 by 3, and the value of b minus 9 upon 9a plus 21 equals to 0. Taking the LCM, we solve this equation and we get minus 77a plus 231 equals to 0, or 231 equals to 77a, or a equals 3. Now from equation 2, we are writing here b equals to minus 9a plus 21. Putting the value of a equals to 3 from here, we get minus 9 into 3 plus 21 minus 27 plus 21, or b equals to minus 6. So on comparing both the types of solutions, we have solved first by taking the relationship between the coefficient and the zeros, and the other method by putting the value of x directly into the given equation. We see that this method is longer and time consuming. Therefore, relationship between zeros and coefficient of quadratic polynomial helps to solve questions efficiently, and we have to find either the variable or two variable. So in all the methods, we will apply alpha plus beta equals minus b by a and alpha beta equals to c by a. Thank you.